Hello everyone, welcome back to my YouTube channel Educator Jeevan. And in today's video, we will talk about the isotope and atomic mass. All the students and all the teachers and all the educators. This fate simulations help us to explain isotopes and atomic mass more easily and more effectively. If you use this, that the students can easily understand about the isotopes and the atomic masses. After playing with all these things, the students will have a very clear concept about isotopes and atomic masses. Let's go into the isotopes first. And one more thing, the link for this will be in the description box below. After watching this video till end, you will understand all about the isotopes and atomic mass, because I will give you all the information about the isotopes and atomic mass. After that, you can go to the link below and just keep on doing by yourself. Let's go for the isotope right now. I'm clicking in isotope. After clicking in isotope, you can come up with this thing. See here, you have seen here the periodic table. You can, there is a symbol, I want this symbol on, and abundance, that's in nature, I just want it on. Here it's done with the, let's try with the hydrogen. In case of the hydrogen, see here, isotope hydrogen 1 means there is only one proton and neutron. Even you can see at the top over here, the proton is only one and electron is only one. There is no neutron in case of hydrogen 1. The mass is 1. And you can see here its symbol how we represent H1 and H here also one is atomic number, this lower one, and the upper one is atomic mass. So this is H1 or hydrogen 1 isotopes, and you can see that in nature you will find it 99.9885%, and other isotopes is very less. Right, now for the next, what you will do, in case of the isotopes, number of proton and electrons are same, right? Here proton, but the difference is with the neutron, because by adding the neutrons you'll increase the mass by 1 atomic unit. Let's go for the next. Yes, when you add the neutrons, the hydrogen 2 isotope is formed, and you can see the symbol over here, 2H1. This upper 2 is the atomic mass, and this lower one is the atomic number. Being isotopes are, those isotopes have same atomic number, but the different atomic masses, because the neutron, it doesn't have play in charge or any other things, it just add the mass, right, at the mass number. You can even see over here in the balance, the mass number is 2 for the hydrogen 2, and still you can see it's stable. And the percentage of you'll get in the environment, it's like 0.0115%. Let's add one more neutron over here. Now see here, hydrogen 3, that means there are two neutrons, one proton and one electron. That's a hydrogen. Since I already told you number of electron and proton is 1, that means atomic number is 1, but we are adding the neutron. As a result, atomic mass of hydrogen is increasing, and we call that as an isotope. This third isotope is your hydrogen 3. Even you can see in the symbol over here, this 3 is the atomic mass, and you can see here it's unstable and mass is 3 shown here in the pen balance. Right, here is only unstable, right, only the trace. This isotope is found only in the trace amount. So if you want to convert that in the atomic mass unit, yeah, you can convert, just click in the atomic mass AMU. Okay, let's try with the next, adding next neutron. What will happen? Just let add over here. Ooh, it's unstable, and see here the abundance in the nature, it's 0%. So the hydrogen 4 doesn't exist, and even there is no value shown by the pen balance, because it's unstable and there is no such kinds of hydrogen 4 isotope. So by using this software, by using this fate simulation, you can even predict whether this isotopes, or no, you will figure out whether this isotope is existing in nature or not. So you can see here this isotope is a 0% abundance in nature, so this isotope doesn't exist in nature, so it's showing unstable, and even the balance is not showing any number. Let's try the different one, carbon. In case of the carbon, you can see there is 6 protons and 6 electrons and 6 neutrons. This is your carbon 12. Even you can see here mass, atomic mass, it's 12. The mass number and the atomic mass of the carbon is 12 because we considered the atomic mass with the reference of carbon 12 atom, right? Let's And you can see here the symbol here also. See, the 6 is the atomic number, and this top 12, that's your atomic mass. Now and you can see the abundance, 98.93% of isotope is present over here in the nature. Let's add one neutron over here. Okay, see, C13, its percentage is 1.07 percentage of carbon 13 isotope is present in the nature, right? These carbon 12 ones. Let again add the next one more and just check it. Okay, it's a carbon 14. It's unstable. Although it's unstable, it is also found in the trace amount. That means, like hydrogen atom, the carbon also have the three different isotopes. That's carbon 12, carbon 13, and carbon 14. Right? And even you can see here in the symbols as well as in the abundance in nature. Now even you can see the atomic mass here, 14. Let's try with the adding one more. Let's try for the carbon 15. This isotope is 0%. That means there is no existence of carbon 15 in the nature. So this means you can easily predict, you know that how many isotopes of carbons are there now, right? You only have how many? There are three: carbon 12, 13, and 14. 14 is also in a very trace amount, very less, right, compared to the carbon 14, carbon 13 and carbon 12 respectively. In this way you can try with the different one. Let's try with the oxygen. Yes, you can to go with the oxygen and go along with the symbols, check the symbols and check the abundances in nature. So by doing this, you will understand that the isotopes, in case of isotope, atomic number is same as number of proton and number of electrons. You are not changing. What you changing, what you adding is the neutrons, is the number of neutrons. So the isotopes are only differ in atomic mass, but not in atomic number. I hope you guys are clear about these things. Now, after completing your isotopes works, you just try play with the number of elements given over here. After that, you can go to the mixture. You can try with the mixtures over here. You can make your own my mix. You can even try with your own mixture, right? Let's erase it. Okay, I want to go with the hydrogen. Let's go for the hydrogen. This is how atomic mass of an atom is calculated. Like in the previous, we knew that in the previous one we knew that the hydrogen has three different isotopes, right? One H1, that's hydrogen, 2H2, 2H1, that's a deuterium or a hydrogen 2 isotope, 3H1, that's hydrogen 3 or tritium. These are the three different isotopes of hydrogen, right? Now see here, accordingly the atomic mass happens here. You can prepare your mix yourself. I'm preparing a mixture of myself. You can see here changing the average atomic mass. The thing is like, the average atomic mass is calculated in a percentage compositions, and finally that's the atomic mass of that particular atom. Like if you talk about the hydrogen, the average atomic mass of hydrogen 1, hydrogen 2, and hydrogen 3, along with the percentage compositions, that is the atomic mass of hydrogen. Here, even you can create your own mix, like if you mixing in your own way, in this way. See here, your hydrogen, your average atomic mass is right 1.17554 am. You can do it yourself. It's like how you can make your own mix. Try very close to the, okay, one. Let's remove this. If I do this one, yes, hydrogen, it's very close to the 1 amu. But if you want to see the nature's mix, like hydrogen 1 and hydrogen 2, then you can just click here in the nature's mix. See here, this one is the nature mix. There is only one green over here. You can see there is one dot green here. That's your hydrogen 2, and remaining are the hydrogen 1. That means the percentage compositions of hydrogen 2 isotope is very very less than the hydrogen 1 isotope. So the mass, you can see the average atomic mass, this is very close to the H1, because the more percentage of hydrogen 1 isotopes are abundant in nature, right? Similarly, you can go with the lithium one. Okay, yes, you can, you just, this is the nature mix. See here, lithium 6 and the lithium 7, you know lithium 6 and lithium, if you compare if you do with the lithium 6 and the lithium 7, here you can find that the lithium 6 is in around 7.59 percentage, and lithium 7 as 92.41 percentage. So this is all about the nature mix, and the mass is almost close to the 7, right? Here it's almost close to the 7, because the more lithium isotopes having the atomic mass 7s are present in nature, right? And even you can try with preparing your own mix, like what we did previously. You can keep on working on it until and unless you are not that much clear. I hope most of you got the idea about the isotopes and about the atomic mass. Hopefully my video is quite helpful for you. If you find my video helpful, please don't forget to subscribe my channel, and don't forget to comment right down in the comment box below. And if you are loving my video, if you love this video, then don't forget to hit like button. See you in the next video. Bye bye all.